Hello everyone. This is a question from JEE Advanced 1994, checking our basics regarding the projectile motion as well as concepts of conservation of linear momentum. Let me read out the question quickly and see actually whatever the information is there in the paragraph, and I'm going to explain with the help of this given diagram. There are two towers of different heights. This is of 20-meter height and the tower of CD is of 30-meter height. Okay, and there is a particle from the top of tower A projected horizontally with speed 10 meter per second. Say that as a speed u, and I can show here it as a u. Simultaneously, another particle from this point, from the tower CD, they have projected with same speed 10 meter per second. Having same magnitude of initial velocity as that of first object as a mentioned data, which means with whatever the speed we have projected from top of tower A, same speed is maintained for the second particle of double the mass from point C, making 60-degree angle with the horizontal. Okay, and they said they collide in air and they stick each other. If this is the case, we need to find two unknowns here, that is finding the distance between towers, okay, this one, as well as find the position where the object hits the ground. Actually, what happens with respect to the ground, any observer from the ground can say what? It has its own projectile path. It has its own projectile path. In their individual journey, there is a chance of having somewhere collision here, isn't it? After collision, as a combined system, where do the particle will land on the ground? That position of the landing point must be finded, and here I have already given some answers for the sake of my reference. I'm going to prove it. How do we can get these answers? See, the dropped point on the ground, the position on the ground where it hits the land on the ground will be 11.55 meter from the B. This is going to be our next target to find, and it is going to be proved as 11.55 meter. Okay, so how are we going to handle this problem? Let me make a self-analysis in this way. See, if this is a tower and one more tower, gap between them is an unknown thing. First we need to find this itself. We have a projectile whose projection is having initial velocity vector exactly horizontally, and it has same u 60-degree angle made with the horizontal, so it will be u cos 60, it will be u sin 60. So directly let me write it as a u cos 60 value as u by 2, u sin 60 as root 3 u by 2. Okay, this is the second particle projected starting from point C. This is the first particle projection started from point A. Now I am not going to deal this problem with their individual journey following their parabolic paths. Instead, let me handle this problem using concept of relative motion, that is making any one of the particle at rest. Let me make the particle at A to be at rest relatively, that is make it as an observer. So next diagram what I can write here is this particle which is at A, because it is relatively at rest, makes this u to be added to the observer in opposite direction, so that it feels that particle at C will have 3u by 2 horizontal vector, root 3u by 2 downward vertical vector. And because there is a collision happening between A and C, because already A is at rest, if collision have to occur, C have to come and meet A. So the collision between A and C will be taken place if and only if the net velocity of these two, say V net, is going to be fitted exactly along the line joining A to C. Okay, so here if this is some theta, by means of sliding this vector here I can find theta value. Let me draw a separate diagram in this way. If this is my V net, as this is root 3 u by 2, you know u is 10, right? Given value of u is 10 meter per second. So value of what I can say here is 3u by 2 is nothing but 15. It will be 5 root 3 and it will be theta. So tan theta value will be 15 by 5 root 3. Obviously it will be root 3, where theta will be declared as 60 degree. Once you got the value of theta as 60 degree, it will be a helpful factor for me to calculate the value of D, because let me draw a parallel line to the D here and say suppose this is some point Q. Okay, as you know that this is of 20 meter height and this is of 30 meter height, and the difference is nothing but 10 meter. So the value of CQ length will be 10 meter, and tan 60 will be again useful for me for the triangle ACQ to say it as a opposite side. Opposite side is nothing but D by adjacent side is nothing but a difference of top two towers height, nothing but 10 meter. So it will be 10. So D value will be 10 into tan 60 root 3. So 10 root 3 meter I can say D value, or in number form you can say, because it is 1.732, it will become 17.32 meter, right? So one of our answer is ready now here. Next thing here is let me find out the V net value. I mean the value of net velocity is going to be what? Let me check once. See here, let me do here. V net will be a root of what I got, 15 square plus 5 root 3 whole square, because 3u by 2 is 15, root 3u by 2 is 5 root 3. Resultant of those two will be in this way. So it will be 225 plus 5 square 25, 25 into 3, 75. It will be again 300, again it will be 10 root 3 meter per second, right? See in this figure you can observe that with this net velocity which you got now 10 root 3, to collide with A, this particle have to travel this AC line length, right? So what is the value of AC line length? Means AC is equal to root of AQ square plus and our CQ square. Okay, so as you got AQ just now, the value of small d as 10 root 3 whole square plus CQ value is nothing but this line length, which is 10 meter, which is nothing but difference of these tower heights. So it will be 10 square. So what you get here is 300 plus 100, 400, which is nothing but 20 meters, right? So now how much time it has taken, how much time does this particle would have taken to meet A or collide with A with the help of net velocity along this line length, which is 20 meter. Obviously because see, once again here there is no relative acceleration between two projectiles, because each projectile has their own individual acceleration which is equal to gravity small g value. So there is no relative acceleration. One feels the other motion as uniform motion. There is no trouble about the A relativity. A relative value is 0. So as there is no relative acceleration, I can say V equal to S by T formula is sufficient to calculate the time S by V, as T equal to S by V. So relative displacement and relative velocity to collide here, it have to travel relatively AC line length as relative distance or relative displacement. So AC value I got just now as 20. So 20 by net velocity value is 10 root 3. So what I got here is a time taken to collide here is a 2 by root 3 seconds. 2 by root 3 seconds. And here, if this is the process of collision, initially it has u towards I cap side. Initially it has u cos 6 star, that is u by 2 towards left hand side of mass m of mass 2m. Now let me calculate the momentum of the system along horizontal direction, along x-axis. See, why do I am going to get the idea of calculating momentum of the system along x-axis? Because in this system the two particles are not having any external force, only along x-axis. Along y-axis I should not attempt considering momentum, because there is a gravitational force which is like an external force. So let me calculate momentum initial momentum. This is like initial momentum. So what I can say, mu I cap, and this is of mass 2m into u by 2, direction is minus I cap. So as you are getting total momentum of the system along x-axis is 0, which means even when they collide here, there is no any horizontal momentum existing for the system of two bodies after collision, right? So immediately after collision, because there is no any horizontal momentum, that system has only vertical velocity. So at the instant of collision, whichever the point is there, from that point exactly vertically downward it have to fall and hit the ground. There is no any horizontal displacement after collision onwards. Okay, so if you find either this distance or this distance, because these are parallel lines, you will be able to answer the position where they landed onto the ground. Okay, let me find out this distance as taking it as a x, as it is parallel to this one. If I find the horizontal displacement of individual projectile, this one, the second question answer will be ready for me. So as you know, horizontal distance or horizontal displacement of this projectile will be horizontal component of velocity into time taken. See, time taken to move from here to here is nothing but time taken to collide. So u into, as you got now 2 by root 3 as time, as u is 10, it will be 20 by root 3 meters. So this value will be the position where combined system landed onto the ground from foot of the tower AB will be at a distance of 20 by root 3 meters, which I have given here. And already I have mentioned that answer in number value here. See, the position where the object hits the ground from B will be 11.55 meter. Actually what we got now here, if you represent in number value, that will be equivalent to 11.55 meter. Okay, this is how this question we can analysis, and hope so this analysis strengthens our basics regarding kinematics concepts.